Dear students, good morning. Last class, I had told you regarding the probability theory part. Discussions were there. I had told you what is the chance, how chance comes up, or which cases we can apply the word concept of chance. Which cases we can say the case of not a chance, like I told, when we are knowing that 3 plus 2 is 5, that time you can clearly say you don't have a chance of getting 6 or 5. The clear result is possible. But in the case of tossing of a coin or rolling of a die, you can say that the concept of chance is there in that case only. Moving ahead, let us discuss few more things, some more theory, and then we'll take up the questions. So the article that we are discussing now is equally likely outcomes. This was the last part that we had discussed. Equally likely outcomes. Lastly, children, if you talk about equally likely outcomes, if you remember my last video, the thing that we had discussed in that is if you are increasing the number of trials, if you are increasing the number of trials in an experiment, then suppose that experiment will be the of tossing a coin. If that experiment is tossing a coin, then your number of heads also will increase, the number of tails also will increase. This was the thing we had discussed. So it is mentioned there, if there is no reason for any other outcome to occur in a preference, other outcome, we must say equally likely. Means if you are doing a particular experiment, all the results have equal chance. Means it is not that you are having a coin and only head will come into that. No. Or you are having a coin and tail will come into that. So this is not possible. So what does it mean? So it means all the chances, all the outcomes have equal possibility. That's what they are mentioning by that theory also, that there is no reason for any one outcome occur in preference. So we are not, you cannot say that if we are tossing a coin, only head also will come and tail also will come. And both have equal chance. 50 50% probability or half is the probability of head to come in a single throw of the coin or tossing the coin one time, and tail also will come. So this is the thing here. Okay, so that is what is meant by equally likely outcomes. All the outcomes of an experiment have same chance. That means same weightage is there. It's not some that particular event has got some more weightage that this one will come in a particular experiment. So all the outcomes have equal possibility of coming. Then event I had told you, event is what? The experiment being done. So it is mentioned here, each outcome of an experiment or collection of outcomes is called as event. Event is what? And children, as I had told, this definition are what? Collection outcomes is born. That example of event would be what? Example of event would be rolling of a die. Then what? Taking out of a card from so many cards. Then throwing a die. Okay. Then next time was favorable outcomes. Might be seen in the PDF of that as well. Favorable outcomes. Favorable outcomes. By favorable outcomes, what we mean is what we desire. Like suppose in a throw of a die, if a die is thrown, how after possible 1 can come, 2 can come, 3 can come, 4, 5 and 6. But if I say I want only 3 to come, I want 3. So getting 3 is one outcome out of the 6 possible outcomes. Yes or no? So getting 3 in the single throw of die is one outcome. So can I say here that number of favorable outcomes will be what? What? Out of what? The total number of outcomes being 6. So if I talk about this case, if I talk about P of 3, children, I have used this particular term or expression here so many times in the solutions of P of 3 means probability of getting 3. It is all equal to what? Favorable outcomes. Favorable outcomes upon total number of outcomes. Total number of outcomes. Not telling if I want 3 as our result in the single throw of the getting 3 is only one time. Out of the 6 outcomes, only one is our favorable. Means one is the number of favorable outcomes. See, total number of number of favorable outcomes. The number of favorable outcomes is 1. And what is the total number of outcomes possible? If we are throwing the die 1 on 10, it is 6. Out of 6 results possible, the one result which is in our favor is 1. That is, one is that number of attachments. Now, some more questions are there. We'll see it once I will fill that PDF part. Suppose I say I want to get even number, E of even. E of even is if we are having even numbers. So how many numbers are even throughout die? 2 is there, 4 is there, and 6 is there. Can I say out of the total 6 outcomes are 3 outcomes in my favor? Yes. So probability of clear we got number of favorable outcomes is 3 and the total number of outcomes 6, and we will not play in this problem. We make it what? 1 by 6. That is the answer. Are you clear on how to take one probability? Probability is always a fraction, and that fraction, the numerator is what? The number of favorable outcomes, and the denominator is what? The total number of outcomes. Clear to all? Then few more things. It is mentioned here. Sure event. Sure event. What do we call sure event? Sure event means it is written here. An event which always happens is a sure event or a certain event. An event which always happens. Always happens. Which always happens is called sure event. And one more thing is given. It is called as sure event or certain event. Certain. Okay, this both the things you remember. We will also ask for the filling of language to go for MCQ type questions also. Now, the question is, what is a sure event? Children, the sure event is what? Like certain event like what? You can say sun rises in the east, every day sun rises in the east, and the sure event. Yes or no? Or one more thing. If you talk about if we are rolling a die, you will get numbers. What you will get? 1, 2, 3, 4, 5, 6. Can you get 7 if you are throwing a die? No. So example is what? Example, getting number less than 7 in what time? That. So if you are solving that time, you are getting number on one number only in this number will be always less than 7 only, and this is sure number. Now for a sure event probability is 1. If I would say, find the probability of number more than 7. What will it be? It will be 0. That means getting this what? Impossible event. Impossible event. Yes or no? But if I say probability of getting a number, then I say all the numbers that you will get in a single throw of time will be what? Less than 7. So that probability of a sure event is 1. That is what I intended to tell you. So probability of a sure event is 1. You can also call it as 100%. And probability of getting some of an impossible event is 0. Clear to all? Then we have questions after this. And there is a special note regarding cards. Playing cards. I have told also. Let me tell you, and I will be telling you also when we are doing questions. Only one question is based on cards. That is on question number 9, if I am not wrong. Question number 9, yes. Question number 9. So cards are playing cards. 52 cards are there. 26 are red cards. And then 26 are black cards. This is one classification. Then in this 52 cards, we have 13 cards, 13 cards, 13 and 13. This set of 13 cards is called as suits. Okay, so these are what? Club. This is club is one suit, and that's what is card. Then there is spade, and then there is okay. We'll discuss more when we do question in this one. So, club, then hearts, diamonds, and spades. And in each 13, all 13 are identical. 26 are black, 26 are red. And in this, there are one card which is called as ace. That was called as Ika. Then the second card is your king. King is shown by the letter A. Third, we are having a card that is queen. You are shown by the letter Q. Then fourth is your jack. Jack and global equal. You shown by J. Now children, this A, Q, and J are also called as face cards. Face cards. One more name is given as picture cards. Okay, face cards or picture cards. One more name is given. You are not going. Well, they are called as code cards. Code cards. Code cards, face cards, or picture cards. After this, other than this 4, see 4 are there. 13 minus 4 is 9. So remaining 9 cards are number cards. What are the numbers there? The numbers start from 2 onwards. So it will be 2, 3, 4, 5, 6. So numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you find these numbers. Ace is Ika, A, Jack are face cards. Then numbers 2 to 10. These cards will have numbers from them. And they are called as what? Number cards. They are called as number cards. Accordingly, we have questions also on this children, that which is number card, which is face card, and all these things. And we have questions, I've told you. And we will be discussing next more things in the next video. Thank you.